Hello! So sorry that I've been away for a while. I've been doing sciencey stuff like writing grants and doing experiments and analyzing data. Awesome stuff. And recently, one of my grants was accepted, and the Animal Behavior Society, animalbehaviorsociety.org, gave me a student research grant, which will allow me to continue studying hormones. Yay! So what I'm going to be using the grant money for is to buy enzyme immunoassay kits, or EIA kits, from Cayman Chemicals. And I'm really excited about how these kits work, so I wanted to explain to you how they work today. So what you use these kits for is to measure concentrations of hormones. So I'm going to be using these kits to look at how parasites affect the amount of cortisol that is produced by California killifish. And so I'm going to explain to you how these kits work because I think it's totally awesome. So I'm going to be buying 96 well plates, and the first 2 rows of the plate are used as standards. And so the values that the rest of these wells the rest of these wells will be filled with your samples, and you'll compare the values from your samples to these standards to figure out how much of your hormone was in the sample. So a lot of work has to go into extracting the hormones, and I can talk about that some other time. So anyway, each one of these wells, I'm going to make this bigger. Each one of these wells along the bottom has 2 antibodies. And so antibodies are just molecules that have very specific receptors that bind to very specific things. So the first antibody binds to the bottom of the plate and holds it there. And the second antibody, which comes off of the first, because it's bound to the first, has receptors for cortisol, for example. I'm going to be buying cortisol kits, so I'll use cortisol as an example. So these bind specifically to cortisol and hopefully to nothing else. And so you've got these wells, and you put some amount of your sample into the well. So it's a known volume, but you don't actually know how much of your hormone is in the sample. So after you put your hormone sample in there, with an unknown amount of cortisol, for example, you then add hormones that come with the kit. And these hormones are also cortisol, but they're bound to what's known as a tracer, which I will describe in a second. So you have some amount of tracer and some amount of your hormone, some amount of kit hormone. I'm going to call it kit hormone, but it's cortisol that comes with the kit, and it's bound to a tracer, and some amount of your hormone that's in there. And so these hormones will competitively bind these receptor sites. And essentially what that means is they'll all bind and then unbind and bind again, so they are able to unbind from the receptor, and eventually they will bind in a proportion that represents the proportion that they're present in this sample. So say, for example, there's 2 times as much of the kit hormone as there is your hormone. So you get about 2 times as much binding on the binding sites. Oh, sorry, yours don't have tracer. And so they bind in a proportion that represents the proportion that they were present when you put them into the well. So after you leave them for like an hour to reach this equilibrium, you then dump out the rest of the fluid that's in the well, and you add what's known as Ellman's reagent into the well. And what Ellman's reagent does, which is really cool, is it makes these tracers that I mentioned earlier glow. I don't know if it's really called glowing, it's emitting a wavelength. And so the more of the kit hormone that's present, the more of this yellow wavelength that gets given off, and the brighter this well appears. So the brightness is inversely proportional to the amount of your hormone in the sample. So the more of the kit hormone that's bound, the brighter it will be, and the more of your hormone that's bound, the less of this wavelength you'll get given off, and the less bright it will be. And so there's a plate reader that will read how bright each of these different wells are, and they will compare the brightness to the standards that you put on the kit, which have a known amount of hormone associated with them. And I think that this is a totally cool thing to have, been able to figure out. And I think to me, it's one of the a really great example of the amazing things that we've been able to do and the things that we know. So first we had to realize that there are things called antibodies, and that these antibodies bind to very specific things, and that you can come up with antibodies that, one, bind to the bottom of a well, and then two, bind to another antibody that has receptors for hormones that are very specific. And then we also had to know how to put tracers onto hormones, and we had to know that these tracers can interact with Elman's reagent to give off a very specific wavelength, and then we were able to create a reader that was able to read this wavelength. And then we needed some mathematical tools to be able to compare this wavelength to the wavelengths being emitted in the standards. The mathematical tools aren't very complex, but still. And to me, it's just so cool that we were able to figure out all of this stuff and manufacture it so that we can use it for our own purposes. So anyway, I think this kit is totally cool, and I wanted to share with you how it worked because I think it's awesome. And yeah. I will keep you posted on how my work with these kits goes, and thanks to the ABS for the money to keep doing it. And I hope you have a good day. Bye!